Hello folks, this is Jim Cropper. Welcome to an introduction to the sensitivity, specificity, positive predictive value, and negative predictive value of medical tests. We'll go ahead and get started with sensitivity. Sensitivity is the ability of a test to identify patients that have the disease. So let's say these 10 people on our left here all have the disease, and in our context of physical therapy, we'll call it a rotator cuff tear. If I have a test that picks up 8 of 10 of those patients as being positive, then those are true positives. Sensitivity then is 80%. 2 of those patients, however, are going to be negative, even though they have that rotator cuff tear. And those are called false negatives because they have the disease and the test was negative. So a test that is highly sensitive is good for ruling out a disease when the test is negative. So if I have a test that is, let's say it's 95% sensitive, if that test is negative, I know with a 95% assurance that I've ruled out that disease. It's used primarily as a screening tool because it doesn't get to the specific problem particularly. It just says that there is a problem. And when you have a screening test like this that becomes positive, then that says, okay, now let's do a test that is more likely to show the pinpoint or the specificity. Sensitivity is not related to prevalence of the disease. So it doesn't matter how prevalent the disease in the population is, the sensitivity of the test is independent of the prevalence. So let's switch over to specificity. Specificity is the ability to identify those without the disease. So these 10 people don't have the disease. None of these people have a rotator cuff tear. And let's say that 7 of 10 of the patients test negative on this test. And so that's a true negative because they don't have a rotator cuff tear and they showed up negative. So the specificity of this test is 70%. 3 of those patients are going to be positive even though they don't have the disease. And so those are referred to as false positives. So a test that is specific is good for ruling in disease when it is positive. It's not related to prevalence of the disease either, just like sensitivity. So neither sensitivity nor specificity are related to prevalence of the disease. So let's talk about a good way to remember this. Ruling in, ruling out, and we go by spin and snout. So that if you have a test that is specific and that test is positive, then that rules in the condition you're testing. Likewise, if a test is sensitive and it is negative, then that rules out the condition. Let's talk about how to calculate this. It's very easy. We have a 2x2 table. We have patients with the disease and we have patients without the disease. We'll say that this left column has to do with sensitivity and the right column has to do with specificity. The top row is the test is positive. So everybody on the top row is positive. Everybody on the bottom row, the test is negative. So now let's talk about sensitivity. We found that we had 8 patients test positive, and those were true positive. We found out that we had 2 patients test negative, but they were false negatives. The formula is to divide the true positives by the true positives plus the false negatives. In other words, everybody, the population. And in this example, the sensitivity turns out to be 0.8 or 80%. Now let's look at specificity. In our example, we had 7 people who were truly negative, and we had 3 people with false positives. The formula here is to divide the true negatives by the true negatives plus the false positives. And that turns out in this case to be 0.7 or 70%. Now let's switch over and talk about positive and negative predictive value using the same grid. Now, positive predictive value is the ability to detect the presence of disease. It measures the probability of having the disease when the test is positive. So in our example, 8 people tested positive for rotator cuff tear, and they had the disease, true positives. 3 people tested positive for having the disease, but they didn't have it, so those were false positives. Our formula is to divide the true positives by the true positives plus the false positives. And in this case, the positive predictive value is 72.7%. And again, it's the probability that the patient has the disease when the test is positive. So negative predictive value, which is the probability of not having the disease when the test is negative. In our example, we had 2 people with false negatives, and we had 7 people with true negatives. Our formula here is to divide the true negatives by the true negatives plus the false negatives, giving us a negative predictive value of 77.8%. So let's talk about negative and positive predictive value. Make some comparisons. Positive predictive value is the likelihood of having the disease when the test is positive, and negative predictive value is the likelihood of not having the disease when the test is negative. Positive predictive value is directly related to prevalence. In other words, as the prevalence of the disease gets higher in the population, the positive predictive value gets higher. Negative predictive value, then, is negatively related to prevalence. So as the prevalence of the disease gets higher, the negative predictive value is lower. So some final words. Sensitivity and specificity are widely used. We talk about them with many tests, and we choose what tests to do based on sensitivity and specificity. Usually a test is not both sensitive and specific. It's possible, but it's very unusual. Highly sensitive tests are for screening, and high specificity tests are used to make that final diagnosis. Now, in the clinic, we use multiple tests. Since we have nothing that's 100%, we'll use several tests, which increases our likelihood of either ruling in or ruling out a problem, usually a musculoskeletal disorder, when the tests are either negative or positive. Sensitivity and specificity are not related to prevalence, where positive and negative predictive values are intimately related. Now, final words for positive and negative predictive value. They are so related to prevalence that sometimes it's difficult, or one must take caution relating the results to the patient unless the statistics were developed on that particular population. So if your patient really is from a different population, the positive and negative values are not of much use, and therefore sometimes also the specificity and the sensitivity. But really it is the best we have to go on. The relationship of sensitivity and specificity to positive and negative predictive value are illustrated very well in this video by Mark Campo, PT, PhD. It's on YouTube. I recommend you watch it. It's only 17 minutes, and it's not required for the course, but it's a good illustration of how the testing really has to be taken advisedly, and why we use multiple tests to help us hone in on what the problem is with our patient. So that's it. Thank you, and goodbye.